Hello dear students, welcome to Global Academy. I am Dr. Vinayak, your physics educator. In today's class we will discuss the topic ray optics and optical instruments, which is unit 9 of 12th class or 2nd PUC. In today's class we will cover these topics. First one is laws of reflection, reflection through plane mirror, spherical mirrors, relationship between focal length and radius of curvature of spherical mirror, mirror equation and magnification, characteristics of image formed by spherical mirrors. First one is laws of reflection. There are especially two laws of reflection. First law says the angle of incidence is equal to angle of reflection. See here, there is a incident ray which falls on the mirror, which get reflected in one particular direction. So here we have drawn one normal. Normal means it is a perpendicular line which makes 90 degree to the plane of the mirror. So here angle of incidence is nothing but the angle made by the incident ray with a normal is called angle of incidence. Similarly, the angle made by the reflected ray with a normal is called angle of reflection. According to first law, the angle of incidence is equal to angle of reflection. So second law says the incident ray, reflected ray and the normal drawn are lie on the same plane. It means, so if you consider the plane of the paper along which the incident ray falls, so then the reflected ray and the normal are all lies on the same plane of the paper. Now let us discuss about what is meant by spherical mirror. Spherical mirrors are nothing but these are the part of the hollow sphere. So here you can see, so a hollow sphere. If you take a part of it, so you will get what? The different parts of the mirror. So there are two types of mirrors. First one is the concave mirror and convex mirror. So concave mirror is a mirror in which the reflecting surface lies towards the center of curvature. What is meant by center of curvature? A center of curvature is the center of the sphere from which you have taken the part of the mirror. So now in the first case you are having what? One smooth reflecting surface and another one is a rough surface. In this case, the smooth reflecting surface is towards the center of curvature, right? So such kind of mirrors are called concave mirrors. In the second case, you are having the reflecting surface which is exactly opposite to the direction of center of curvature. So here in the second case, the center of curvature is lies on the one side. In its opposite side, you are having the reflecting surface of the mirror. So therefore, second is an example for the convex mirror. So in optics, it is necessary to know the sign convention. So first sign convention says, if you are measuring all the distances above the principal axis, such distances are taken as positive. For example, the height of the object above the principal axis is taken as positive. However, the height of the object below the principal axis, which is taken as negative. So in the second case, this height is taken as negative. In the first case, the height is taken as positive. Okay. So next, if the light rays travels from left to right, if you are measuring all the distances against the incident ray direction, such distances are taken as a negative distances. Suppose if you are measuring the distance opposite to the direction of incident ray. Here the incident ray direction is left to right. If you are measuring all the distances opposite to the direction of incident ray, which is taken as negative. However, if you are measuring the distances in the direction of the incident ray, such distances are taken as positive distances. So these are the 4 sign conventions. So now let us discuss about the relationship between the focal length f and the radius of curvature. What is meant by focal length? Focal length is the distance between the pole and the focus. What is meant by focus? Focus is the point if you are making the parallel rays to falls on the surface of the concave mirror. So here after reflection all the rays are appears to meet at one particular point on the principal axis. That point is called focus. The distance between the focus and the pole is called focal length. Similarly, the distance from the center of curvature to the pole, so this distance is considered as radius of curvature. So this is the concave mirror and this is the convex mirror. So in case of convex mirror, if you are making the parallel rays to fall on the reflecting surface of the convex mirror, after reflection all the rays are appears to come from one particular point on the principal axis. That point is called the focus. So the distance, similarly here the distance from the pole to focus is called focal length, right? Here also the distance from pole to focus is called the focal length, which is represented by the symbol small f. However, the distance from pole to center of curvature, this distance is called radius of curvature. By watching this figure, you will come to know here the distance between the focal point or the focus to the pole is exactly half the distance between the center of curvature to pole, right? So therefore, here you can write the focal length is equal to half of the radius of curvature. In both the cases, we can find the relationship between the focal length and radius of curvature is f is equal to r by 2. Hello dear students, are you preparing for NEET JEE or K-CET? Looking for the right guidance to achieve your dream rank? Welcome to Global Academy live coaching classes for NEET JEE and K-CET, a single point and complete solution for competitive exam preparation, specially designed for 11th, 12th, 1st and 2nd PUC students, combining board syllabus with a entrance exam preparation. New batches are starting from 25th March 2026 for the academic year 2026-27. Fee structure rupees 9,999, 50% discount of 4,999 for the entire course. Call these numbers for further enquiry. Scan QR code for easy payment. So now discuss about what is meant by mirror formula. So mirror formula gives the relationship between the object distance, image distance and focal length. So which is related by the equation 1 by v is equal to 1 by u plus 1 by f. Here v represents the image distance, u represent object distance and f represents focal length. So this is what we are calling as mirror formula. So now we will discuss about the lateral magnification. Lateral magnification, which is represented by the symbol m, which is the ratio of the height of the image to the height of the object. So that is bi by b naught. So here bi represent what? Height of image and b o or b naught represents height of object. Similarly, one more formula we are having for the magnification, that is minus v by u. V I already told it is the image distance and u is the object distance. So next, one more formula you are having, that is equal to f divided by f minus u, where f is the focal length, or one more formula that is equal to f minus v divided by f. So these all are the formulas for the lateral magnification. So now let us discuss about what is the position and what is the nature of image formed by the two types of mirror we are having. First one is the concave mirror and another one is the convex mirror. So let us first discuss about how the image formation occurs in case of the concave mirror. See here, if you keep the object at infinity, so you will get the parallel rays, right? So after reflection through the parallel rays, all the reflected rays are going to pass through the one particular point is called focus. Means the image of an object which is at infinity is formed at a focus. So next, if you keep the object just beyond C, so here the object is not at infinity, just beyond C. So after reflection, all the rays are appears to meet at the point B dash and A dash. So means the image of an object beyond C is formed between C and F. Similarly, if you keep the object at a C, that is center of curvature, the image formed at C only. So here in the third case, here the image height and object height is same. Okay, in the first case you are having the point image. In the second case you are having the object height is more, however the image height is less. Here this is the inverted image. Okay, so and it is a real image. Real images are those images which can be obtained on the screen. If you keep the screen at this place, you will get the image of the object. So in the third case also you are having what? The size of the object and size of the image are same, and it is also a real image as well as inverted image. So in the third case, in the fourth case, here you are keeping the object between C and F. After reflection, the image is formed beyond C. Here this image is also a real image, inverted image, and the size of the image is more than the size of the object. In the fifth case, here you are keeping the object at the focal point, that is F. So after reflection, the image is formed at infinity. Means you are not getting the image here. So image is formed at infinity. So next, in the sixth case, you are keeping the object between focal length and the pole, focal point and the pole. So the image after reflection, here it will forms the image beyond P. Means so the image is formed inside the mirror, right? Here the A dash B dash is the image which is enlarged, but you can't able to keep the screen inside the mirror. So therefore this is what virtual image. This is a virtual image and it is a erect image, and its size is enlarged compared to the size of the object. So if you compile all these things, so you will get this kind of the table. So when the object is at infinity, the image position is at the focus. When the object is beyond C, you will get the image between focal point and center of curvature. If you keep the object at C, you will get the image at C. If you keep the object between C and F, you will get the image beyond C. So if you keep the object at F, you will get the image at infinity. If you keep the object at P and F, you will get the image behind the mirror. So and the nature of image is tabulated in this table. So now in case of the convex mirror, where the image is formed, so that let we can see. So first one is, if you keep the object at infinity, here the image is formed at F. So you know that if the object is at infinity, the rays are coming from that R or parallel to the principal axis, right? After reflection, they are appears to pass from one particular point is called focus where the image is formed. So therefore, to obtain the image of an object at infinity in case of the convex mirror, you will get what? The point object at a focus which is inside the mirror. So means this is a real or virtual image. It is a virtual image, and it is diminished image. So the size of the object is more and size of the image is very small, or point image it is, right? So next, if you keep there is a one more possibility here. You can keep the object between what? Infinity and the pole. So there is no other possibilities are occurs in case of the concave convex mirror. Okay, so here when we keep the object between the infinity and pole, you will get the image which is formed between pole and the focus. So here also you will get what? The size of the image is smaller than the object. So this is also a diminished image or the small image, and it is a virtual image because the image is formed inside the mirror. You can't able to obtain it on a screen. So therefore, if you tabulated all these things in a table, you will get this information. First one is the position of the object at infinity. You will get the position of the image is at focus, so that is behind the mirror. Okay, so which is the virtual and the erect image. So next one is, if you keep the object between the infinity and the pole, you will get the image position between pole and the focus, so which is also a diminished image compared to the size of the object, right? So this is for the today. In the next class, we will discuss about some MCQs on this topic. Thank you.